All right, little change of scenery. We didn't finish this section in class the other day, and now we're headed into a long holiday weekend, so I don't want to make people wait. So finishing up 4-4, the next topic is finding reference angles. Finding reference angles for angles greater than 360 degrees or less than negative 360 degrees, aka greater than 2 pi or less than negative 2 pi. So basically, there's just one extra step at the beginning. Find a positive angle less than 360 degrees or less than 2 pi that's coterminal with the given angle. And then after that, it's just like the problems that we were just doing. So let's look at some examples. Okay. So the first example is we're going to find a reference angle for 665 degrees. So again, start by finding the smallest positive angle that's coterminal with that angle. Looks to me like if we subtract 360 degrees just one time, that will put us in the right range at 305 degrees. So now it's, again, just like the problems we were just doing, it helps to draw a picture of the angle. And I managed to find one. So 305 degrees is over in quadrant 4, which means the reference angle will be 360 degrees minus 305 degrees, which is 55 degrees. I know in the picture it says negative 55 degrees. So the person who made this picture was using it for something else. Remember that reference angles are always positive. So we don't pay any attention to whether they're measured clockwise or counterclockwise. So the reference angle for 665 degrees would be 55 degrees. All right, next we have 15 pi over 4. So again, the first step is to find the smallest positive angle that's coterminal with that angle. And we've had lots of practice with doing that with radian angles. So one way to do it is to think of 15 over 4 as a decimal. That will tell you how many times you need to subtract 2 pi. So look at this 15 over 4 here. And if I ask my calculator what that is as a decimal, it comes out to 3.75, which means I can only subtract 2 pi one time. So that's what I'm going to do. 15 pi over 4 minus 2 pi, getting the common denominator would be 15 pi over 4 minus 8 pi over 4. That gives me 7 pi over 4. And I believe that 7 pi over 4 was one of the examples in the last batch when we were finding reference angles. So again, that picture looked like this. That angle is also in quadrant 4. So I am going to subtract that angle from 2 pi. And I find that the reference angle for that angle is pi over 4. Pi over 4, this angle right here. All right, and then the last example is a negative angle, negative 11 pi over 3. So again, if I change just negative 11 over 3 to a decimal, that'll tell me how many times I need to add 2 pi to get into the interval that I want. So I asked the calculator, what is negative 11 over 3? And it's about negative 3.67. That means I need to add 2 pi twice, right? If I only add it once, it's still going to be negative. Okay, but if I add it twice, that'll put me into positive territory. So I'm going to add 4 pi. And when I get the common denominator for 4 pi, it turns into 12 pi over 3. The coterminal angle with negative 11 pi over 3 is pi over 3. And I didn't bother putting a picture for this one because pi over 3 is already in quadrant 1. And if your angle happens to be in quadrant 1, it is its own reference angle. All right. So now that we know how to find reference angles, it's very easy to evaluate a trig function at absolutely any angle. So let's work on that now. The values of the trigonometric functions of a given angle theta are the same as it turns out, as the values of the trigonometric functions of the reference angle theta prime, except possibly for the sine, SIGN. A function value of the acute reference angle theta prime is always positive, right? Because that angle is always between 0 and pi over 2 or 0 and 90 degrees. However, if you think back to all students take calculus, the different trig functions have different signs, SIGNS, in the different quadrants. So we're going to use the quadrant that the original angle is in to figure out whether our function value should be positive or negative. So let's do some examples. Actually, let's talk officially about how to do this first. The value of a trigonometric function of any angle, I see a couple typos in here. All right. The value of a trigonometric function of any angle, I think this is supposed to say theta. And find the associated reference angle theta prime. That's supposed to say theta prime. Okay, typos fixed. Find the associated reference angle theta prime, and then find the function value for theta prime. So if you know your quadrant 1 angles really well, especially for sine and cosine, then step 1 shouldn't be hard. Okay, and then in step 2, we're going to use all students take calculus to figure out whether the trig function should be, whether the function value should be positive or negative. Okay, the first example of using reference angles to evaluate trigonometric functions, we're going to find the exact value of sine 300 degrees. So remember, the first step is to find the reference angle for 300 degrees. 300 degrees is in quadrant 4, which means that the reference angle will be 60 degrees. So what that means is that the sine of 300 degrees is either equal to sine 60 degrees or negative sine 60 degrees. And to figure out which one it is, we know that 300 degrees is in quadrant 4. All students take calculus, calculus meaning that out of sine, cosine, and tangent, only the cosine is positive in quadrant 4. Okay, so we know that the sine of 300 degrees is either square root of 3 over 2 or negative square root of 3 over 2, but because we know that the sine is negative in quadrant 4, we know that the sine of 300 degrees is the opposite of sine 60 degrees. The sine of 300 degrees is negative square root of 3 over 2. Next example, we're going to use reference angles to find the exact value of tangent 5 pi over 4. So first step, find the reference angle for 5 pi over 4. 5 pi over 4, I want you to think about this for a second. Which quadrant is that in? Hopefully you know that 5 pi over 4 is in quadrant 3. So if you draw a picture of 5 pi over 4, I don't think I have one here, you find that the reference angle for 5 pi over 4 is pi over 4. So I'm going to go ahead and evaluate the tangent of pi over 4. So one way to do that, well, there's two ways to do that. You could either memorize sine, cosine, and tangent for the special angles in quadrant 1. I think we had a chart, might have been in the last section, that showed that the tangent of pi over 4 was 1. The other way you could do it is to remember that the tangent is the sine divided by the cosine, and hopefully you know that the sine of pi over 4 and the cosine of pi over 4 are both square root of 2 over 2. So when you divide a number by itself, you get 1. Okay. All right, so that tells me that the tangent of 5 pi over 4 is either 1 or negative 1. So we're going to go to the quadrant for 5 pi over 4, which we already said was quadrant 3. All students take meaning tangent. Tangent is the only one of those three functions that's positive in quadrant 3. So the tangent of 5 pi over 4 is going to be exactly the same as the tangent of pi over 4. The tangent of 5 pi over 4 is going to be 1. All right, and I believe this is the last example. We're going to use reference angles to find the exact value of secant negative pi over 6. Okay, there's two ways you could do this, and I actually, I don't know that using reference angles is my favorite way to do this. Of course, negative pi over 6 is the mirror image of pi over 6 through the x-axis, right? It just means it's been traced clockwise. Okay. So the reference angle for negative pi over 6 will be pi over 6. Okay. So, all right, they're doing it, I think, a more complicated way. So they're, first of all, finding a positive angle that's coterminal, and then they're going to find the reference angle for this angle. All right, sometimes you have to do it this way, but I think this one is a little simpler than this. So then the reference angle for 11 pi over 6 is pi over 6, because 11 pi over 6 is in quadrant 4. Okay. All right, so now we have to think about is the secant positive or negative in quadrant 4? Well, all students take calculus doesn't really help with that. You have to know that the cosine and the secant have the same sign, SIGN, right? Because they're reciprocals of each other. All students take calculus. Cosine is positive in quadrant 4, which means the secant is also positive in quadrant 4. Okay. So now I'm going to evaluate the secant of pi over 6. Okay. Didn't really show my work here, but the secant of pi over 6 is the reciprocal of cosine pi over 6. All right, so I'll leave it to you to check that. Well, we know that the cosine of pi over 6 is square root of 3 over 2. So I'll leave it to you to check that the reciprocal of square root of 3 over 2, once you rationalize the denominator, is 2 root 3 over 3. Okay. All right, so that's the secant of pi over 6. And because secant is positive in quadrant 4, the secant of negative pi over 6 will also be 2 root 3 over 3. Just a quick comment. This particular problem, there's a much, much simpler way to do it, right? We know that secant is an even function, which means that the secant of negative pi over 6 is exactly the same as the secant of pi over 6. So you don't even really have to think about reference angles if you do it that way.